Hello ladies, sorry I can't be with you today, but we are going to take a look at chapter 9 and start this section. So a lot of this orange notebook right here, naming ions, part of it is review. We're going to just hit a couple main points, and I'm going to introduce polyatomic ions to you. So first we're going to identify the charges on monatomic ions by using the periodic table and naming the ions. We are also going to define what a polyatomic ion is, write their names and formulas for the most common polyatomic ions. Then we'll identify the two common endings for the names of most polyatomic ions. So a lot of this right here today is once again review, but it will also be posted online for your viewing later. So let's take a look at this page right here, and if you notice, I have many different languages here. So let me give you a couple seconds to just take a look at it and kind of try and figure out what it says. Some of you may already have some key pieces. This green one right here, if you take a look, and I'm going to highlight it just to point it out to you guys. This right here is Swahili. Some of you may have already kind of figured out what this says, but what it says is, may peace prevail on earth. Has something to that meaning, okay? So the importance of this is we need to really understand the language used, right? So in chemistry, we have our own language, and just like you learn rules for the language, the foreign language you're taking, whether it's French or if you're taking Spanish, you have to learn the rules. You have to know how to conjugate, you have to know feminine versus masculine. It's the same thing in chemistry, except we don't conjugate and we don't have feminine and masculine. We have different terms that we take a look at. So today you're going to start learning the language of chemistry, which you will continue to use throughout the whole school year. So let's take a look at the word monatomic ions, and let's take a look at some of these words. I have monopoly, monogamy, monoglyceride. So in all three of these, what is the thing in common? Right, so I'm hoping you notice there is the prefix mono in each one. So whether you play the game Monopoly or you know what a monopoly is, that means, in Monopoly, there's always one winner, right? One person who owns the entire board. So we'll just keep count of one, right? Monogamy means one marriage, right? One wife, one husband. And then monoglyceride, that's another science term which also means one sugar. So this keyword mono, or in this case we're going to say mana, means I have one. So a monatomic ion is a one atom, right? One for mono, atomic is atom, ion. These are the ones that we've been using. So you've learned about cations and anions, but it's these monatomic ions that we have been using these past couple of weeks. So just as a reminder, cations tend to lose their valence electrons so that they can gain stability, right? And remember, the key thing about stability is we're trying to become very similar to a noble gas. So just to refresh our minds, how do we find the number of valence electrons? So, well, part of this is already showing, but when the metals of group 1A, 2A, and 3A lose electrons, they form cations with positive charges equal to the group number. So for example, let's use my favorite one, sodium. If you take a look at sodium, just like what we've done in our previous example, sodium is 1A, right? So since sodium is in 1A, we know it wants to lose one electron, right? If I were to draw this, I would draw this one valence electron here. It's most likely going to give that away so that it turns into a positive. So if you take a look at this, it says metals in group 1A, 2A, and 3A lose their electrons. Sorry, let me lower that for you. Lose their electrons, so they have positive charges equal to that group number. So we have our regular Na. Once it gives away that electron, right? So this electron is going to go away somewhere. It's now going to change into an Na plus. And if you take a look at your ion sheet that I've given you, for the most part, you're not going to have to memorize these. You'll eventually memorize them, but this is just a couple tricks for you guys to see. So let's go ahead and take a look at our next slide. Let me just fix this real quickly. All right. So, sorry about that. What we'll do is let's take a look at this next section right here. Our anions. Okay, so our anions, the charge of an anion of a group from group 5 to 7A is always a nonmetal. What we're going to do is we're going to subtract 8 from the group number. So our charge is always the group number. Is always the group number minus 8. So let's take a look at chlorine, right? Chlorine is right here, and it's in group 7A. So according to this rule, it says the charge is equal to the group number minus 8. So if I do that, I get my group number is 7 minus 8. This gives me a negative 1. So if I'm taking a look at chlorine, and if you look at your ion sheet, chlorine becomes a Cl minus 1. That's because of this math right here. And just to refresh our memories, anions are named by taking the stem name plus the IDE. So my chlorine is no longer chlorine, but this blue right here is called chloride. So let's do another example. Let's take a look at, let's take a look at fluorine, right? So find fluorine on your periodic table. It's the letter F, and it is found in column 7A, right? So if I were to follow this rule, the charge is equal to the group number, in this case is 7 minus 8. This is also equal to negative 1. So what do you think the charge on my fluorine will become? Good. It's going to be this negative 1 right here. So I would write fluorine as F with a negative power. And instead of fluorine, it's now become fluoride. Just like what you see in your toothpaste. Okay? So let's go ahead and try this out. Except I do want to point out things in group 4A and in group 8A, they tend to not form ions. We know that 8A does not form ions because what kind of elements are these? Good, these are our noble gases. And they are already stable. Oops, gases. They're already stable, so they have no need to give away or to receive electrons. Group 4A, on the other hand, is slightly different. They're halfway filled. So sometimes they can't decide, should I give them away or should I take 4? So we're not going to touch group 4A or 8A electrons, ions for this matter. Okay, transition metals are that orange area. They go from groups 1B through 8B, and they tend to form more than one ion with different charges. So the key thing is this word different charges. Whereas, for example, sodium is always going to want to give away one, or bromine is always going to want to receive one. Our transition metals can give away or receive more than one. So the charges on the cations of many transition metals must be determined by the number of electrons lost. And the one thing is, this needs to be given to you, which is also why I give you the ion sheet, so that you can use that as reference. Alright, so let's take a look at how we name our transition metals. The first thing is, we use stock name and Roman numerals in parentheses to indicate the charge. So, for example, if I have an Fe3 plus ion, I'm going to call it iron 3 in parentheses ion. So let's highlight that to make sure we see it. I need to say the word iron. Oops. I'm going to say the word iron 3 ion. Okay? So that's how this is done. The other thing is the transition ions with only one ionic charge do not need the Roman numeral. So if this was, let's say, let's use a pen that you guys can see. If I had Fe plus, I wouldn't have to write iron 1. I would just call it iron. It's implied that it only has one charge. And if I scroll down, one last piece right here, and that is, we use root words with different suffixes, but not as useful since it doesn't tell us much about the charge. So this is something that you may see, but we're not really going to worry about this so much. Okay. So let's actually practice and name some of these ions and state their charges. So find selenium for me. Good. Selenium is Se. And what column is it in? Good, I hope you said 6A. Since it's in 6A, I know that it has to receive electrons. It's very close to becoming stable if I had picked up two more. So I'm going to use the equation where I take the group number. So my charge is equal to the group number of 6 minus 8. That gives me -2. So selenium will become Se2 minus, and since it's an anion, it's called selenide. Okay. Let's go ahead and find barium. If you find barium, which is Ba, barium is in column 2A. Since it's column 2A, I know that this is going to be a cation. It's going to want to probably give away those two. And if it's a cation, my charge is just the number of my column. So since it's 2A, this is a 2+. And if I name this, this is called barium ion, just like on your ion sheet. And finally, let's do phosphorus. Phosphorus is the letter P. It's in column 5A. Since I'm in 5A, I know I'm going to be an anion. And what I'm going to do is I'm going to take my charge is equal to the column number, so 5 minus 8, which is equal to -3. So phosphorus has a 3 minus charge, and since it's an anion, is phosphoride. Okay? So let's go ahead and take a look at polyatomic ions. Since we've done a lot with monatomic ions before. So let's take a look again. If you notice, the three commonalities in these words, the one thing that in common in these words is the word poly, right? What does poly mean? In math, polynomial means many terms, right? Polygamy means many marriages or many wives, many husbands. Polymer is a very large molecule in chemistry, which means I have many different pieces to this. So a polyatomic ion is many atoms. So now we're going to use those different the different ions on your ion sheet that I told you not to look at. But now we are going to look at them. So a polyatomic ion is composed of more than one atom. Most end in with the suffix ite or ate. So if you take a look, there is a sulfite and a sulfate. Right? And I'm doing this from memory, so if I remember correctly, sulfite is an SO3 minus, and a sulfate is a SO4 2 minus. Correct me if I'm wrong, I'm not quite sure if that's correct. But if you notice, it's polyatomic because I have an S and an O. Isn't that more than one atom? Here I also have an S and an O, but specifically I have 4 O's. So if you notice, many of our polyatomic ions will end with this word ite or ate. You're not going to need to memorize these because you do have your ion sheet to make reference to. And that's the end of this section. We're going to now take a look at, now that I know the names of these things, how do I combine them to create our different compounds? Thank you.